Welcome back, mathematicians. Here we are, another lesson in Algebra 1. So let's jot down some notes. Let's title it Lesson 10.3. And the topic is the Pythagorean Theorem. So that's how you say it, Pythagorean Theorem. Okay, so that's the topic of the day. And it is named after the Greek mathematician Pythagoras. And it is believed that his students discovered this relationship, and then he was credited with the find. Alright, now the relationship that his students found, that in every single right triangle, so that's important, you have to have a right triangle. Alright, if it's not a right triangle, this relationship does not exist. So in every single right triangle, if you measure the leg and you square it, and you measure the other leg and you square it, and you add those results, it will always equal the hypotenuse squared. Okay, there it is. That is the Pythagorean theorem. Now, if I'm going too fast, pause the video. You can rewind or re-watch. So, I highlighted in red everything that's important. The Pythagorean theorem only works in right triangles, and it works in every right triangle. And the measurement of the leg squared added to the length of the other leg squared will always equal the hypotenuse squared. Okay, so what in the world is a leg and a hypotenuse? In a right triangle, the legs are the two sides that meet at the right angle. Alright, they meet at the right angle. So those are the legs. It doesn't matter which one's which, okay? So legs make the right angle. And then this long side over here, this is the hypotenuse. And the hypotenuse is always the longest side. Hypotenuse is always the longest side. Okay? And this works in every right triangle, so let's just show you here. So if you take this leg, and let's say I measured it and it was 3.2 centimeters. So you take that leg length and you square it. And then you take the other leg length and square that value. It will equal the hypotenuse squared. And it does matter that you do the legs first and add those, and then the hypotenuse. Hypotenuse is opposite. It's across from the right angle. See how it's across from it? The legs make the right angle, and the hypotenuse is across. Alright, and the hypotenuse is 8.9 squared. Alright, so if I grab a calculator and I type 3.2 and square it, it's 10.24. And then if I type in 8.3 and square it, 8.3 times 8.3 is 68.89. And then 8.9 squared, 8.9 times 8.9 is 79.21. When I add these two together over here, 10.24 plus 68.89, it would be 79.13, which is very close to 79.21. And they would actually equal if I measured it more accurately. Okay? They would turn out exactly equal. Alright, so let's learn more about this. So let's draw a right triangle. Okay, now remember, a right triangle has to have a right angle. And this is going to be a leg, and this is going to be the other leg, and this side is the hypotenuse. The legs always form the right angle. Okay, the legs make the right angle, so they make this right angle here. Those are the legs. The hypotenuse is always the longest side. It's always the longest. And they use letters for these, okay, because mathematicians like shortcuts, so they don't want to write the words. So one of the legs is A, the other leg is B, and the hypotenuse is always C. So instead of writing leg squared plus leg squared equals hypotenuse squared, many times you're going to see A squared plus B squared equals C squared, okay? And it does matter. The hypotenuse is always C. Hypotenuse always goes here. The legs here, hypotenuse here. All right, let's try an example. So here we go. Examples. So number 1. Let's say you have a right triangle. And you know that A equals 5 and B equals 12. And you're asked to find C. Okay, since it's a right triangle, since you know it's a right triangle, you know that A squared plus B squared will always equal C squared. So A squared, A must be a leg, B squared, B is 12, equals C squared. And then just follow your order of operations. Exponents come before addition, so 5 squared is 25, 12 squared is 144, and that equals C squared. 25 plus 144 is 169 equals C squared. And then remember, the opposite of squaring something is that you take the square root of both sides. And the square root of 169 would be plus or minus 13. And the square root of C squared is C. But since this is a triangle, you would not have a measurement of negative 13. So the hypotenuse, which is C, must be 13 units long. So you just plug the numbers in, and it does matter. Legs go for A and B. Hypotenuse is always C. Notice the hypotenuse always turns out to be the longest. 13 is longer than 12 or 5. All right, here's a second example. Again, let's say you know you have a right triangle. That's a symbol for triangle. And let's say B equals 3. You're told B equals 3. C equals 3.4. And let's say you don't know what A is. All right, so A squared, or leg squared, plus the other leg squared, which is B squared, is always going to equal C squared. And you just substitute in. So A squared, we don't know A. B squared, B is 3, so 3 squared. And C is 3.4, but we have to square it. Okay, so A squared, I don't know A squared, but 3 squared I know. 3 squared is 9. 3.4 squared would be 11.56. I just used my calculator. Now we just solve. So let's subtract 9 from both sides. You get A squared equals 2.56. And then the opposite of squaring is take the square root of both sides. So you'd get A equals, and just use your calculator, square root of 2.56 is plus or minus 1.6. But again, you can't have a length of a triangle be negative 1.6, so it must be positive 1.6. So that's the other leg. There's a leg, and the hypotenuse is always the longest. Okay, I'm going to do two more videos, but I'm going to put, or sorry, two more examples, but I'm going to put those on the next video.